Hi everyone, just quick, I wanted to say that this is actually going to be the last Nailing Science on my channel. Don't worry though, it's not going to be the last Nailing Science ever. It's just that my channel has grown so much since we posted the very first Nailing Science video. It doesn't seem like the most appropriate place for it anymore because this is such a space-focused channel. So instead, it's going to be moving to a channel that Michaela's involved with called Oxford Sparks.
Yeah, which is the University of Oxford's science engagement place, i.e. the place where you'll find all the cool science happening at the University of Oxford. So we'll have Nailing Science and a bunch of other things besides. Link below to check that out.
Yeah, I think it just made sense to move it to there because that's the place where a lot of discussions between researchers happen anyway. So it makes sense to put a broader discussion with researchers on a channel that's specifically designed for that. But don't worry, it's not the last ever Nailing Science. We are in CERN right now in Geneva in Switzerland, so you can probably guess what our next researchers' topic that they study is. And so look out for that in a couple of weeks over on the Oxford Sparks channel.
Hello, scientifically accurate nail art lovers, and welcome to another episode of Nailing Science with me, astrophysicist Dr. Becky Smethurst.
Me, molecular biologist Dr. Michaela Banks.
And this week's special guest is volcanologist Professor Tamsin Mather.
Hello.
Welcome.
Thank you.
But yeah, so we've already painted a base coat, haven't we? So we should probably show people what's on, first of all, your left hand that Michaela's going to be painting.
Would you like me to
Sure,
model
yeah,
some
please
of
model
blue?
for us.
And this is called Mint Condition. I'm going to depict your last field trip involving a volcano. So there's the sky that the volcano will be against,
Okay. So
and some other magical technology.
Okay, which we'll get to, I presume. Okay, so I've gone for a similar theme of sky.
Would you like me to
Because
model?
yes, this
There we
right
go.
hand actually is a white for sort of interesting thing that I'm going to do, which we'll hear about later, and then goes through sort of grey to then a dark blue, which is kind of like volcano ash through to space coloured through the atmosphere.
Volcanoes are kind of like really interesting in loads of different ways. Because probably most people think of them as being natural hazards, and you sort of think of destruction, destruction, and disruption to people's lives, or worst case scenario, loss of life. And that is very true.
Is that disruption, destruction, and death?
D cubed. But then they're actually also really useful resources. So Iceland, for example, a really significant amount of their power is actually generated from geothermal power. Ethiopia, where we do a lot of, or have been doing a lot of our work recently, we're looking at the way that the hot water basically flows through the volcano, so that you can then tap into that and make electricity. But then they've also played a really key role in the evolution of our planet. So in lots and lots of different ways. So, volcanic environments are one of the first environments that are potential candidates for the first molecules of life. Volcanic gases have helped to maintain our atmosphere. But then also when we get these really heightened periods of volcanic activity, that can cause really big biological changes. So when life has started, like the mass extinction events, for example.
Yeah.
So I like studying volcanoes because I'm just really interested in all those different aspects and how all those different aspects fit together.
It's funny how much crossover there actually is between our three fields, right? Because obviously your molecular biology, which is sort of the tiny life things, which obviously can come from volcanoes, and then so we've got the crossover with sort of like the formation of planets, and then the effect that then volcanoes can have in atmospheres, like Venus's atmosphere and like Io's atmosphere, there's space volcanoes that can sort of change a planet's atmosphere. And then,
absolutely. I had a student studying Venus actually a few years back.
Nice.
So I when I was younger, I wanted to be an astronomer or an astrophysicist. So I had to settle for
lost you to
volcanoes somewhere along the line.
To be fair, if you were going to get swayed by anything,
Volcanoes are pretty cool.
I'd take volcanoes or penguins as an acceptable answer. So how do you actually study a volcano without, because obviously you can't go into a volcano because we die, presumably.
Yeah.
I know there's lots of different types of volcanoes and everything, but how do you actually study it? What data do you collect to do it?
Well, lots and lots of different types of data. So you said, we can't go in because we die. It's absolutely true. You wouldn't go into an active volcano right now for very obvious reasons. But then you have ancient systems that have become extinct themselves, and then sometimes they get kind of cut in half by different processes.
What about current volcanoes? How do you actually study those without getting too close?
So some of the techniques we use would be, I mean, you're looking at all sorts of different clues the volcanoes are giving us. So if they're throwing out rocks, you might take some of those rocks. I've got a chest full of them just over here.
It's a really cool chest.
Yeah, well, you can basically go and then bring those back and have a look at them and see what sort of crystals you've got in there,
Right.
see what other sort of clues that gives you. But then you can also put instruments out on the ground. So seismometers are a really key data source that we use. So you put, if you're lucky, you put several around the volcano. If you don't have so much resource, then you might just put one. And then you look at the very, very small earthquakes that the volcano is making. And I guess a little bit like taking the pulse of the volcano.
Oh, okay.
So it's like when gas or magma, which is what we call lava, when it's in the inside the earth, when they move, they give a little sort of heartbeat, if you like, or they sort of vibrate anyway.
That's not how a heartbeat is so much nicer than the way I thought. I was like, so basically listening to like the stomach gurgle of a volcano,
Okay.
but a heartbeat. This is much prettier way of thinking about it. So
Very, very romantic.
yeah, exactly than what I thought of.
And then sometimes, you know, the lava is forcing its way through cold rock, and then that rock is breaking, and that gives you a different type of
Oh, okay,
stomach
cool.
rumble,
Yeah.
or heartbeat, whichever way we're going with this. And you can take you measure those signals, and then try and look for patterns in them and make sense. And, you know, on the very basic level, it's just a matter of, you know, how fast is the heart beating, or how gurgly is the stomach. If you must.
We must.
So you know, that on the very basic level, is it quiet or is it making some noise? But then if it is making noise, what's that noise telling us? Where's this magma going? Where's the gas going? What's happening? What's going to happen next? Of course, volcanoes, you know, you can look at what they look like in the visible, which is, you know, what we can see. But also heat is really, really important in terms of volcanic volcanoes. So you can look at changes in the infrared part of the spectrum. So you can look at changes in terms of their thermal signature, you know, so whether it's again increasing, decreasing, where the hot spots are, and things like that. And you can do that from space as well as ground base. So
From
that's-
space!
Yeah.
We got space in it!
Didn't take very long.
No. All conversations
That's
lead to
right.
space.
And then you can also look at when they're changing in shape.
Is that what this is? This cool
So
rainbow
Yeah,
thing?
so I was going to come on to that. So that's actually then another way we can do it is using radar satellites. And this is the output from a radar satellite.
But I was drawn to this immediately because I'm a magpie and I love colours. So this is something I'm going to definitely do on your nails.
This is the white one.
Yes, is
Yeah.
I'm going to try and recreate this, famous last words, and have a satellite as well as my plan. Because I walked into the office and was like, oh, what is that? But so how is this made? So you just said it's radar, just bounce back.
So the radar satellite goes on. It goes around the Earth, and it sends a radar down, and bounces off the surface and comes back up again. And it looks at the phase. So the satellite records what you know. You say, you know, you've got the peaks and the troughs, like a bit like
Sine
waves
waves,
on a bit like on the surface of the ocean. You've got peaks and troughs, and the satellite records. You know, are we in a peak or are we in a trough? Are we halfway?
Yeah.
Then, say a few weeks later, it comes back and it covers over the same place on the planet, and it sends the beam down again, and it records again which part of the wave.
Because if it's in the same place, you'll get, like, if you got a peak the first time, if it's in the same place, you'll get the same place in the peak back. But if it's moved, you'll get a different...
Yeah,
That's
exactly.
really cool.
So that's called an interferogram.
Interferogram, that's such a cool word. Interferogram. That sounds like something from, like, the Avengers, doesn't it? Like, with my vibranium shield, I will make an interferogram.
I
like
can't
the
believe they
normal-
haven't used that.
You listen to us, Russo brothers. Interferograms.
Marvel Cinematic Universe. You have nothing on that. It's interferogram girl.
That would be a cool, like, spandex, lycra outfit.
I don't think I could pull it off, but
Wait, I would not care about pulling
With
it
a
off. I'd
cape.
still wear it and be like, I'm interferogram girl.
this is like a contour map, if you like, of the deformation. So the closer these like pretty rainbow patterns are together, the more the change in the shape is
Okay,
of
cool.
the surface of the planet.
Nice.
we've been talking a bit about kind of how you tell what's going on underneath the volcano, and another thing you can use to tell what's going on underneath the volcano is how much gas is coming out, because as magma...
See, stomach rumbles.
So we're going to get on to other body noises if we're not careful.
So I'm going to say it. So volcanoes are the Earth's belching or flatulence, but I'm going to go with belching.
Belching's a nicer word, isn't it? Yeah.
Yeah, okay, yeah. Sometimes, yeah.
If it's belly rumbles,
I love how we just come into your office and I'm like, so you study the volcano equivalent of farts? We're so childish.
Yeah,
We just come in and be like,
Beavis and Butthead.
yeah, it's bad of nail polish. Of science.
So,
Tempting to draw the world's smallest satellite.
I know.
It's going to be a cube sat.
I was going to say a cuticle sat. So if you go from the bottom of a swimming pool to the top of a swimming pool, you can feel like the pressure changes on you.
Yeah.
And sometimes your ears pop, for example. So that is because there's less fluid, there's less liquid above you. And the same thing happens inside the volcano. So if you go from deep within the volcano or the magma plumbing system to shallow, the pressure drops on the magma. And this means that some of the gases that are dissolved in the magma start coming out and forming bubbles. So it's a bit like, if you've got a bottle of Coke, or and when you take the cap off, you like release the pressure on the Coke, and you get all the gas starting to come out. So if you've got magma again coming from deep within the earth to shallow and potentially going to erupt, you get you get gas coming out, and that finds its way out sometimes through cracks in the earth, and that gives us another clue. Once you've got some volcanoes that are erupting for really, really long periods of time, or active for really, really long periods of time, and then it becomes a sort of different, it's a bunch of different scientific questions that come into play. Some are about, if you've got a lot of ash in that plume, where that ash is going to go, and
like with the Icelandic eruption a couple of years ago when all those flights.
Which Icelandic volcano was it?
Go on, Becky.
I don't remember, but I know it was I remember being in the newsroom.
Can you say it?
Well, not perfectly, but I can do something that is approximate. Ayafat-iyakit.
Okay, that's not what I remember.
Anywho, so the ash, where the ash goes.
So one of the things that we're interested in is if we get another, not necessarily Iceland, but in some part of the world, another eruption like that with the potential to really disrupt airspace. Doing a better job still at actually being able to monitor and predict where the ash cloud's going to go, so that you minimise, so that the community can basically minimise the impact on everyone's travel plans. The airline industry, and but also obviously ultimately keep people safe. So that's one aspect.
And the environmental impact presumably as well.
Yeah, so I was going to say, but then the gases also have big environmental impacts as well. So it's not so much the ash, but if you get really gas rich plumes, they cause acid rain, poor air quality.
Sulphurous gas then? Or?
Yeah, so it's a lovely cocktail of stuff that comes out of a volcano.
Really?
So water's a big component, which actually isn't too much of a problem because we've got lots of water in our atmosphere already. It's quite variable. Again, you notice the amount of water in our atmosphere is quite variable. So, it's not a big impact having a lot of new water put out into the atmosphere. It can be a bit more if it gets high up in the atmosphere. But the next most common, the next emissive gas is carbon dioxide. So again, we've got quite a lot of carbon dioxide in our atmosphere, but we are quite interested to know how much is coming out of volcanoes. It helps
percentage?
Well, it helps us to give a context for how much mankind is putting out.
Okay, so when people are like, well, is it really just nature? Is it mankind? Is that get that sort of here's the comparison, and wait, we could be putting it over a tipping point kind of thing? Is the
but so people will try and make the argument, volcanoes put out volcanoes put out so much carbon dioxide that what we're doing is negligible. There's no evidence that's the case.
Good to
Our
know.
best estimates are about like 100 times less carbon dioxide coming out of the world's volcanoes than what human activities
That's
are
crazy. If
doing.
you think about like the sheer scale of a volcano, and like you think back to those like pictures of the Icelandic volcano eruption and Mount St Helens and everything, like the fact that we can put out 100 times more than that, I think that puts it into perspective to people in terms of like, okay, here's your everyday thing, and then manufacturing all together and airplanes, like it's 100 times of like all volcanoes. It's just ridiculous.
Yeah, but it actually is why we need volcanoes as well, because the carbon dioxide the volcanoes have put out have kept things in balance. So if you switched off the volcano, so like Mars, you don't have any significant volcanic activity these days, and the atmosphere's eroded away, and
Nothing left.
you've got and you've got very, very cold surface temperatures.
Yeah.
So we want some carbon dioxide in the atmosphere, just not too much.
Yeah.
We want the happy pot between Mars and Venus.
That's right.
So you're storing gas and ash, and so this says ash.
Yeah.
Ash collected by drone. Ooh,
Yeah,
drone.
About 10 days ago I got back from Stromboli in Italy, which is a volcano just sort of northeast of Sicily. So you fly into Sicily and then you take a hydrofoil over, and it's in these beautiful islands called the Aeolian Islands, which are gorgeous. So we were there, and the reason we were there is that Stromboli puts some small ash plumes out. When we were there, it was about once every 10 minutes, a little ash plume of different sizes would go up. Yes. Yeah. And they've had a couple of rather larger ash plumes, which they call paroxysms, which would be a little bit more which would be a little bit less cute, a little bit more
Concerning.
Yeah. So we were there because we wanted to use again infrared spectroscopy, so looking at the thermal image of the ash. So the ash is hot when it comes out of the volcano, and the ash is hot compared to the dark eternity of space. And so what we want to do is to use that information that comes out of the infrared spectra to tell us more about the ash that's coming out of the volcano.
Cool.
And we want to do more learning about doing it from close by a volcano, so that we can do a better job from satellites when a big eruption like Yerka goes off and chucks ash that goes really, really long distances. We want to do a better job at satellite remote sensing the ash.
Cool.
So what we were doing is we were measuring infrared spectra from the ashy plumes, and then we also had some drones with us, and we wanted to collect ash from the same ashy plumes, so that now we can make measurements of that ash back in the lab.
So you can
So that
compare
we can-
measurements from the actual thing to what you see.
Yeah, in the spectra.
Yeah.
So that we say, so this is what we know is there. This is what we thought we had from looking at these spectra. And have we done a good job?
But is that the ash like
so
these
what we
black
did
spots?
is we were the only way we could get into the plume was using a drone, and actually it was really challenging to get the drone into the volcanic plume, because it's quite a dynamic environment.
I can imagine.
Yeah.
Plume.
And now I'm going to try and recreate my spirally thing. So are you doing something ashy then over there, Michaela?
This is Stromboli, right? You sent me a picture of, and it has a little. You can just see a little ash plume.
Oh,
Is
is
that
that
right?
a little
Coming off the
poof?
side.
Very delicate.
So, like, and I'm now going to attempt to paint this here drone.
So this was done by a guy called Chris at Manchester University of Manchester.
Yeah.
And essentially what he did, so we needed a way of collecting the ash. This was our first attempt. And what he did is sort of strip down a hoover, as far as I can work out.
A vacuum cleaner.
Yeah, including a hoover bag, and we'd fly it into the drone and then he'd switch the hoover on, essentially. I think that the drone was mainly in the plume from the northeast crater,
Okay.
but there was other activity going on at the other craters at the same time.
So it could be
a mixture,
right,
Yeah.
I
So
see.
that's what all went means. It's they all exploded.
And I just love like the high technicality of this. You've got like a hoover bag that I imagine you could just pick up anywhere, and it's covered over with gaffer tape,
Yeah.
So it's
This
like really
science is a
high
really
tech.
distract from
Yeah.
funding.
Yeah,
It's
so
amazing what you can do though with
when
like,
people are
very
like-
basic equipment.
yeah,
Like, it's
when people are
amazing.
saying why are we spending so much money on stuff?
It's
Guys,
really
seriously. Like,
literally like tax pounds went on buying Hoover bags.
But that will hopefully yield information
Yeah.
that will mean that next time our fatty yogurt goes off,
Yeah.
we
can
won't
do it.
have to ground
We
all
won't
the
have, we won't
flights.
have to ground the flights at costs of billions of pounds.
Yeah.
So like, the way you say next time, like I bet everyone's forgotten about that and been like, oh my gosh, yeah, it can go off again.
Oh, but what
Probably
about
not
the...
the same one, but
Yeah.
And then there's like all the doomsday preppers who need to get ready for the big one.
Oh, you said Yellowstone.
Yeah. Or are there other...
No,
Potential
one
big
of the
ones, or
ones
is it
I
just-
remember from I watched I very nearly became a volcanologist after I watched this documentary program as a kid.
we just nearly
There's
swapped
always,
lives.
yeah, there's always that like one documentary program right, that always like probably reels you in, and it talked about Yellowstone, but I think it was just like a general natural disasters that could like completely destroy the USA or something. And one of them was one of the Canary Islands. As a volcano, and like if it went off, it could collapse the entire side of the island, send this massive tidal wave that could completely destroy the eastern seaboard. And I was like, what?
It could.
It could.
Could not.
Yeah.
It's potentially more likely it would go slowly, go in stages.
Oh, okay.
So you wouldn't get like one massive catastrophic
Well, that's
collapse.
good to know.
Yeah.
Phew. So what's the most spectacular volcanic event that you have witnessed
good question.
firsthand?
Oh.
Or like best field trip, maybe, I guess. Or
Ooh, that's a good question. During my PhD, I went to Chile for 6 weeks,
nice.
and we were working both in the high Atacama. So again, where
the telescopes
where
are.
the telescopes are.
Funny
There is,
that.
it's a part of the is it Hawaii and the high Atacama are
Yeah.
these sort of
And
places.
the Canary
Yeah,
Islands.
there's this sort of weird hookup where you meet astronomers, and
Yeah, but we have to put it on the highest places, and the highest places are usually formed by volcanoes, right? that
That's
have-
right. Yeah. So it's always this sort of funny cultural shared experience between astronomers and
And
volcanologists.
just imagine like the volcanologist like trooping back as like the sun sets, and astronomers
Yeah.
trooping up as the sun sets.
Science and shifts, man. Science and shifts.
Oh, look at it. It's a
It's
little
my
bag.
Hoover drone.
Oh my gosh,
Yeah.
it's the Hoover drone! But you got to show that off. Show process.
There we go.
So you have to do a lot of like climbing and stuff to get to these places, like,
Or can you do it from like
or can you just stroll
sea
up?
level?
Because are they
It really varies
quite...
actually.
Okay.
So we were just talking about the high Atacama, and the volcano we were working on there was called Lascar volcano. So it's quite close to San Pedro de Atacama,
Sure.
and it's 5.5 kilometers altitude.
Right.
So and we
Wow,
we
that's
did climb
quite
that, and we did carry equipment, and that was one of the toughest things. It was probably the toughest physical thing I had done
Sounds it.
prior to childbirth.
So what's harder, climbing a mountain or giving birth?
That's a question I never
So
thought
there we
of.
go. Depends on the mountain and depends on the birth. So that was really tough, and that was obviously it was carrying the stuff, but it was also the altitude as well, which was really tough. But then you get other volcanoes, like Masaya volcano in Nicaragua, that's only about 600 meters above sea level,
Okay.
and actually there's a road that goes all the way to the top. So you know it's not really you've got Masaya's in Nicaragua, and you've got some some really traditional looking volcanoes, your proper kind of cones sticking up above the landscape. In Nicaragua, but Masaya, you could easily drive past it without really noticing it too much. So it really varies actually in terms of how physically demanding it is. And then of course, if you're doing satellite remote sensing, you can do that sitting at your desk.
Oh yeah, this is my life.
in whichever part of the world you choose. So that's not too demanding at all. But yeah, I mean the field work in the high Atacama was probably amongst the most spectacular, just because it's such an amazing place. It's quite remote. So we were sleeping in a local in this village, Talabre, and we were staying in their schoolhouse because it was during their summer holiday, and it was a tiny little village. I think it had a sort of maybe 60 to 80 inhabitants.
Do you have to do much with like locals in terms of Like,
Education?
well, no, but, well, yeah, that as well, but I'm just thinking, like, do any of the local inhabitants around these volcanoes see them as, like, sacred and...
Yeah,
stuff?
well, on lots of different levels, actually. And, I mean, first thing is that never go into country without making contact with the local geological survey
of course,
and the local scientists. And the local scientists have so much to offer in terms of they know their volcanoes better than anybody else,
of course, yeah.
on the whole. And of course the geological survey is often where the buck stops in terms of managing any hazards that are arising from the volcanoes. So we're always working, or at least working with the knowledge of local agencies and scientists, hopefully working with them, because that's the best thing.
Yeah.
And then, yeah, we will do lots of different degrees of outreach, really. So some places like, when we've been working in Ethiopia, one of the postdocs who was here in Oxford at the time organised a big fundraising campaign for a local school near where we were working, and went in and did some very specific outreach at the local school. Also, did fundraising to get a solar panel put in, so they had electricity
really
in the
nice.
school. So there's lots of different degrees of stuff.
I always say I think the biggest like draw for science is honestly the travel. Like you get to travel to so many different places that you would otherwise never go.
And you interact with the communities there in a totally different way as well. I think.
Exactly.
As I say, working with the local scientists is always a real highlight for me.
Yeah,
When we were in Ethiopia, we often take master students from Addis Ababa University come out into the field with us.
That's cool.
It's always really interesting learning about them. And one of the students just started a PhD with a colleague of mine in Belgium, and really exciting to sort of make those connections as well. But you were asking about spiritual beliefs about volcanoes. So just to give you an example, when we went to work on Kilauea volcano in Hawaii, one of the park rangers took us to do it was wonderful. It was a really small ceremony in honour of the goddess of the volcano Pele, up by the Halemaumau crater, which is a sacred site, I think in native Hawaiian. And so, I think we each took a flower and threw it into the crater, and she said some words in native Hawaiian, and it's actually something I really appreciated that we did that. I mean, we did it because it was culturally sensitive to do it, but actually I really appreciated doing it, because it's worth, when you go and work on these volcanoes, they are forces of nature, and it's worth taking that pause just to remember that they are to be respected. And also and how important they have been in local cultures.
Okay, so what I have done is created the little story of the interferogram picture. So we start with the little satellite in space over here. Look at this little star because he's in space.
Sorry.
So it's a little CubeSat, and the gold is the little solar panels on the satellite. And then we've got the waves coming off the satellite, the radar that's being pinged down to Earth, which my nail art skills weren't good enough to keep it all the same wavelength, so they get slightly redshifted hilariously, but we'll ignore that. And then on the film, I've tried to recreate this interferogram. But I think it's really cool, and you got a hollow top coat on it just to make it shiny.
Pleased with that.
Why not shiny?
You're going to be distracted in meetings, just like
Shiny, yeah.
And then on my hand, what's on my other hand? So what you have here is a couple of volcanologists standing out on a very lovely day, and they're looking at this here, Henry the vacuum cleaner drone. You can just see the little bag hanging down, that's where it's sucking up the ash. And then this is Stromboli here, and then just on the edge there, which is totally accurate to the photo. There's just a little gas and ash plume there, and then the just scene continues there.
So this is the point where we get you to basically choose your favourite. But we help you out. We help you out by giving you a little sort of how would you mark sort of out of 5. First of all,
No one told me about this.
It's first of all, it's the lookability. So how many times are you gonna be like ooh in the rest of the day? And then the second one is scientific accuracy.
Oh, okay.
So let's start with my hand. How would you rate this on lookability?
I mean, it was just the whole hand, or
yeah, like just all the fingers, you know, together, just like.
Well, it is really sparkly.
It's sparkly.
It is, you know, sparkly. So yeah, I think good sparkliness.
Okay,
Yeah,
so would
it's
that be
good
like
look. I reckon we're gonna
You're leading.
for a witness. Okay, I'm gonna give you a 5 for sparkly lookability. Yes.
Okay, and then what about scientific accuracy?
Well, I'm a little troubled about the red shirt.
Okay, I'll take that.
This is the thing. If you're gonna do waves, you have to do them accurately.
I'm probably gonna have to mark you down a little
That's
bit.
fine. I can.
3, should I say?
I can live with that.
Okay,
I can live with that. That's okay. Yeah.
I'll
I
be
won't
checking
hate you
with
for
her.
it.
So anyway,
Lookability on Michaela's hands.
shiny.
Not shiny. No, you're right. Not shiny, but there's some very nice touches. What did I give you? I gave you a 5. I'm going to give you a 4 for lookability, but also I love the drone. I love the drone with the proper hoover bag hanging underneath.
So you're going to get scientific accuracy.
And the fact that you were careful enough to put the vent not at the highest point of Stromboli.
With the picture.
Yeah. So I'm sort of saying a 4 or 5, I think, for scientific accuracy. I think I'm going to say a 4.5.
Which pips me to the post by half a point. But we will also ask people to put in the comments which was their favourite, and they can vote and we can see if the people agree. So that wraps up another episode of Nailing Science. Thank you very much to Tamsin Mather for joining us
Yeah, my pleasure.
this afternoon and letting us subject you to this nail polish a-thon.
Palooza.
Yeah.
Look at that. There we
polish
go.
I know.
Palooza.
Yeah,
There
see,
we
are your thumbnails your
Yeah.
favourites?
I think they probably are.
Yeah. If you want to hear more from Tamsin, then I will link her website below, which has links to all of the podcasts you've been on and the Royal Society lectures that you've done as well, which is all about volcanoes, how they lead to extinction level events. So there's dinosaurs involved in that as well, which is always fun. And you've done Infinite Monkey Cage before as well.
That's right, yeah.
And you've done podcasts with Oxford Sparks.
Yes.
So lots of different links you guys can follow if you want to hear more about Tamsin and volcanoes.
Yep. Thank you.
Yeah. And we will see you next time for more scientifically accurate nail art. Bye!
Over on Oxford Sparks. I see like you're squeezing things. Don't do that.